Hi everyone, it's Mrs. Meehan, and in this screencast, I am going to go over Newton's second law of motion. So recall that an object doesn't change its velocity unless a force acts on it. How does an object respond to a force when it is applied? Well, when the force is applied, the velocity will change. And remember that a change in velocity over time equals an acceleration. Therefore, when you do apply a force to an object, it will accelerate. Newton's second law identifies the relationship between acceleration and force. When a net force is applied to an object, the object accelerates. Note that the word net means overall or total. We'll discuss this in further detail later, but for now, just think of sigma F as any force on an object. So when you do look at the equation here, sigma represents net, F represents force, so we have net force on the left side of the equation. Net force is equal to mass times acceleration, also known as F equals ma. That is Newton's second law of motion. For the unit of force, the SI system unit is called the Newton, abbreviated by capital N. Looking at this broken down, mass is measured in kilograms, kg. As we know, acceleration is measured in meters per second squared. Therefore, the unit of force, the Newton, can be found from the second law. So mass times acceleration is equal to kilograms times meters per second squared, also known simply as the Newton. So when you write the units for force in any of the upcoming problems, that unit is going to be the capital N, or the Newton. Let's try a couple practice problems here. So a 3.5 kilogram object experiences an acceleration of 0.5 meters per second squared. What net force does the object experience? So the equation you are using is Newton's second law, so net force equals mass times acceleration. See if you can figure out the answer from that. Okay, so hopefully you got the answer 1.75 newtons, so that would be the second choice here. You know that the mass is 3.5 kilograms and acceleration is 0.5 meters per second squared. What does the net force equal? In this case, you're just plugging in mass times acceleration, which gives you 1.75 newtons. What force is required to accelerate a 1,000 kilogram sports car at 6 meters per second squared? The correct answer is 6,000 newtons. So again, you have mass and you have acceleration. So plugging it into the Newton's second law equation, F equals ma, it's the mass times acceleration, which you were given, gives you 6,000 newtons. A 12 Newton net force acts on a 36 kilogram object. How much does it accelerate? Okay, so for this one, you have to rearrange the equation since now you're solving for acceleration instead of force. So we're given the force, which is 12 newtons. The mass is 36 kilograms. We're solving for acceleration. You need to rearrange the equation. So basically, you're going to multiply mass on both sides so that you cancel out mass on this side and move it to this side. So acceleration is equal to net force divided by mass. Plug in your values, and you get 0.33 meters per second squared. A bat strikes a 0.145 kilogram baseball with a force of 5,800 newtons. What acceleration does the baseball experience? So again, we're solving for acceleration. Therefore, we are going to rearrange F equals ma to A equals F over m. So your acceleration equals the net force divided by mass. Plug in your numbers, and you get 40,000 meters per second squared. An electric model train is accelerated at a rate of 8 meters per second squared by a 12 Newton force. What is the mass of the train? This time we're solving for mass, so we're given net force and acceleration. You take your F equals ma equation. This time you'll divide acceleration from both sides. So mass is equal to net force divided by acceleration. Plug in your numbers and you get 1.5 kilograms. An Olympic sprinter accelerates at a rate of 3 meters per second squared by applying a force of 189 newtons. What is the runner's mass? So we're given net force and acceleration, and we have to solve for mass. Again, mass is equal to net force divided by acceleration once you rearrange the original equation. Plug in your numbers, and you get 63 kilograms is the mass of that runner. Last question in this section. How much net force is required to accelerate a 0.5 kilogram toy car initially at rest to a velocity of 2.4 meters per second in 6 seconds? Okay, so this one's a little tricky. I have a couple steps here. We're given mass, which is 0.5 kilograms. Initial velocity is 0 since we're starting from rest. Final velocity is 2.4 meters per second. Time is 6 seconds. And we're solving for net force. Our first step is we need to use the kinematics equation stated here. So the V equals V0 plus AT. And we're going to solve it for acceleration. So acceleration in this case, we can cancel out the 0 here. So initial velocity is 0. When you rearrange the equation, divide time from both sides, you end up with this. Acceleration equals velocity divided by time. You notice that is the definition here of acceleration, so the change in velocity over time, essentially. Plug in your numbers. Your final velocity was 2.4 meters per second, divided by the provided time, which was 6 seconds, and you get 0.4 meters per second squared. So we now know the acceleration. We can take that information and now apply it to the next step. So using the Newton's second law equation, so net force equals mass over acceleration, we're trying to solve for net force. And now we know the acceleration, which we didn't know previously. So mass we know is the 0.5 kilograms. We know that acceleration here is the 0.4 meters per second squared. Multiply those values, plug them in for ma, and you get 0.2 newtons as the answer. Now, what you noticed in the problems there is that you can rearrange the equation to better see how force, mass, and acceleration are related. So remember, by dividing mass from both sides, you can make the equation now equal to acceleration. So acceleration is equal to net force divided by mass. What this means is that the acceleration of an object is directly proportional to or dependent upon the net force acting upon the problem. As the force acting upon an object is increased, the acceleration of the object is increased. Since this is now a proportion here, both acceleration and net force, if you see an increase in either of those, you'll see an increase in the other. So those are directly proportional. On the other hand, acceleration is inversely proportional to the mass of the object. So we have acceleration up here, mass down here, in this proportion, that is an inverse relationship. So as the mass of an object is increased, the acceleration is decreased. So it would be an opposite effect here. Increase the mass, you decrease the acceleration. Let's try a couple practice problems. So a net force F accelerates a mass m with an acceleration a. If the same net force is applied to mass 2m, then the acceleration will be the answer in this case is C. The acceleration would be halved. So acceleration divided by 2. Recall that this is because the relationship between acceleration and mass is inversely proportional. So as the mass of an object is increased, the acceleration of the object is proportionally decreased. So since we are increasing the mass by 2m, that would result in the opposite effect on the acceleration. So for this case, the answer is C. A net force F accelerates a mass m with an acceleration a. If the same net force is applied to mass m over 2, then the acceleration will be here we have the opposite. So again, mass and acceleration are inversely proportional to each other. So if whatever happens in one, the opposite will happen in the other. In this case, the mass is being halved. If the mass is being halved, then acceleration is going to double. So B, or 2a, or 2 times acceleration, is the correct answer. A constant net force acts on an object. The object moves with the answer is A, constant acceleration. Remember, if a force is acting on an object, there will be an acceleration. Also recall that acceleration and net force are directly proportional to each other. So if there is a constant net force acting on the object, then there is also a constant acceleration happening. So constant acceleration, or A, is the correct answer. A net force F acts on a mass m and produces an acceleration a. What acceleration results if a net force 2F acts on a mass 4m? The correct answer for this problem is A, acceleration divided by 2. Taking a look at this algebraically, we know that acceleration is equal to the force over mass. Now, if we were to compare it to an acceleration, I'm writing a prime symbol here so that you can differentiate it from the initial acceleration here, the original equation. So we're looking at a force 2F over a mass 4m. So we have our F over m, which is equal to acceleration. And we have a fraction here, 2 over 4, which you can basically simplify. So the acceleration in this case, if you write it out, it would be half a, or you could just write it out as the acceleration over 2 divided by 2. So in this case, the answer is acceleration divided by 2, which is choice A. Okay, final question. The acceleration of an object is inversely proportional to d, its mass. So remember, when you rearrange Newton's second law here, F equals ma, A is equal to net force divided by mass. This is showing an inverse proportional relationship. So the answer is D. The practice problems that are associated with this lesson are chapter problems numbers 1 through 4 and 10 to 14, which you can find posted to Google Classroom. Let me know if you have any questions about this lesson.